So we ended with this theorem called the binomial theorem, and it says that x plus y to the n is the same as the summation k going from 0 to n choose k, x to the k, y to the n minus k. And if you write it in expanded form, you get n choose 0 times y to the n plus n choose 1 times x times y to the n minus 1 plus n choose 2, x to the 2, y to the n minus 2. And OneNote is stuck again. Okay, so and dot dot dot, you get at some point n choose n minus 1, x to the n minus 1 times y plus n choose n, x to the n. Now notice that n choose n is just going to be 1. N choose n will be 1. N choose 0 will be 1 as well. Okay, n choose 0 is 1. Remember, we had the we have the convention that 0 factorial is what? 0 factorial is 1 by convention. Okay. Now, so basically x plus y to the n, when you multiply x plus y n times, we are saying that you're going to get bunch of powers of x and y multiplied together with bunch of coefficients and added together, right? So I mean, how do you justify the equation? How would you justify the equation? So in order to justify the equation, notice that x plus y to the n is the same as, so let me take it, so x plus y to the power n is the same as you're multiplying x plus y how many times? You are multiplying x plus y, so there are n factors here, right? N factors. Now what are we saying here? We are saying that the coefficient of x to the k, y to the n minus k is n choose k, right? Isn't that what we are saying? The coefficient of x to the k, y to the n minus k is n choose k. Well, let's do an example. Like, what is the, let's try to verify. When you multiply n factors of x plus y, right? How are you going to accomplish the multiplication? Notice that you're going to have to pick one term from each factor, right? When you multiply them, you're going to pick one term from each factor and then multiply them together, right? Is that how you're going to multiply? Pick one term from each factor there and then multiply them, right? Is everybody clear on that? So let's try to figure out what should be the coefficient. What is the coefficient so what is the coefficient of x to the, I don't know, let's pick 2, y to the n minus 2. Is that clear that the total exponent will always be 1, right? The total exponent will always be 1 because you have n factors, right? Each factor has two summands, x plus y, right? So remember, when you are multiplying them together, you have to pick one term from each factor and then multiply them together. So the total exponent will always be n, right? Is that clear to you? Because I'm going to be picking n terms, right? X or y. So I'm going to be multiplying n factors, each of which is either x or y, right? Is everybody clear? So when you multiply x plus y n times, in that case you're going to multiply, you're going to pick one term from each factor and multiply them together, which means when you multiply them together, every term, the exponent or the total exponent of every term will be n, because you're picking n factors, each of which is either x or y. So the total exponent will always be n. So what is the coefficient of x squared times y to the n minus 2? Well, how many ways can you obtain the exponent 2 on x? How many ways can you get that from that product? How would you get x to the 2? Well, you have to pick x exactly from 2 of the factors, and from the remaining factors you have to pick y, right? If you want to get x to the 2, y to the n minus 2, right? From from 2 factors you have to pick x so that you get x squared, and from the remaining factors you pick y, right? That's how you get y to the n minus 2. Is everybody clear? So the question is, how many different ways can I pick two x's, right? Well, there are n factors, right? There are n factors. From the n factors, I want to pick 2 x's, right? So how many ways can I do that? How many ways can I pick 2 x's? There are n factors, right? How many ways can you pick 2 factors of x out of n factors? It's n choose 2, right? So there are n choose 2 ways of picking 2 factors from which we take x, and from the remaining factors we pick y, right? So the coefficient of x to the 2 x to the 2 y to the n minus 2 will be exactly n choose 2. Is that making sense? And generally speaking, instead of 2, if I pick k, x to the k, y to the n minus k, what's the coefficient of that? Well, the way you get x to the k, y to the n minus k is that you have n factors of x plus y. You select k of them, and from the k of them you have to pick x. From the remaining n minus k factors you pick y. Right? From k of the factors you pick x. From the remaining n minus k factors you pick y. That's how you get x to the k, y to the n minus k, right? How many ways do you get x to the k, y to the n minus k? Well, basically, how many ways can I pick k factors out of the n factors from which I pick x? How many ways can I pick k factors from the n factors, right? And so this is n choose k, right? So this is an easy counting argument for why that equation holds, why the binomial theorem holds. Okay. All right, so here is an example that I would like to go over. So the question here is, what is the sum k going from 0 to n choose k? Can someone tell me what's the value of that sum? What's the value of the sum k going from 0 to n choose k? Well, so if you look at x plus y to the n, that summation k going from 0 to n choose k, x to the k, y to the n minus k. If you plug in 1 for x, if you plug in 1 for y, what do you get? If you plug in 1 for x, 1 for y, what do you get on the left? Two to the n, right? Okay, good. 2 to the n on the left. What do you get on the right? When x is 1, y is 1. What do you get? You get the summation of just n choose k, right? So that's what I have here. So this summation is exactly 2 to the n. So this is saying the sum of the binomial coefficients n choose k, where k varies from 0 to n, is exactly 2 to the n. Is everybody okay with that? Any questions on that?